The year was 1957, and the world held its breath as a metallic sphere no larger than a beach ball traced its silent arc across the star-studded canvas of night. Sputnik 1, weighing just 183 pounds, had shattered more than the Earth's atmospheric boundary. It had obliterated America's sense of technological supremacy and thrust humanity into an era where the heavens themselves became a battlefield. In the sterile corridors of the Pentagon, military strategists huddled over classified briefings, their faces illuminated by the cold glow of tactical displays. The Soviet achievement wasn't just a scientific triumph, it was a declaration of war fought with slide rules and rocket fuel. If the Russians could place a satellite in orbit, they could place a nuclear warhead anywhere on Earth. The implications sent shockwaves through the highest echelons of American defense. But as the public marveled at grainy telescope images and listened to Sputnik's haunting radio beeps, a far more sinister conversation was unfolding behind closed doors. In smoke-filled conference rooms beneath Washington and Moscow, military minds began to contemplate something that would have seemed like pure science fiction just months earlier: the weaponization of space itself. The moon, that ancient sentinel that had watched over human civilization since the dawn of time, suddenly took on a new significance. No longer was it merely a romantic symbol hanging in the night sky. It had become the ultimate strategic high ground. From its surface, 240,000 miles above the Earth, any nation could observe, communicate, and potentially strike anywhere on the planet with impunity. The implications were staggering. General Thomas Power of the Strategic Air Command put it bluntly in a classified memo dated October 1957. Control of space means control of the world. The nation that first establishes a permanent foothold on the moon will possess an advantage so decisive that it could dictate terms to every other country on Earth. These weren't the words of a science fiction writer. They came from one of America's most senior military leaders. The public narrative of the space race spoke of scientific achievement, national pride, and humanity's noble quest to explore the cosmos. President Kennedy's stirring words about choosing to go to the moon not because it is easy, but because it is hard, would inspire generations. But beneath this inspiring rhetoric, a darker current flowed. The moon wasn't just a destination, it was a prize to be claimed, fortified, and potentially weaponized. In the Soviet Union, similar conversations were taking place in the shadowy halls of the Kremlin. Chief designer Sergei Korolev, the enigmatic figure behind Soviet space successes, found himself pulled between his genuine passion for exploration and the increasingly militaristic demands of his political masters. The moon, in Soviet strategic thinking, represented not just a scientific achievement, but a potential fortress from which to project power across the entire Earth. As 1957 gave way to 1958 and the Americans scrambled to catch up with their own satellite launches, the true scope of what both superpowers were contemplating began to take shape. This wasn't just about beating the other side to space, it was about ensuring that when humanity finally reached for the stars, it would do so with weapons in hand. The space race, as the world understood it, was merely the public face of something far more ominous, a shadow conflict to militarize the heavens themselves, with Earth's ancient companion, the moon, as the ultimate prize. Deep within the labyrinthine corridors of the Pentagon, a project so audacious and classified that even its name seemed lifted from science fiction was taking shape. Project Horizon, officially designated in March 1959, wasn't the product of wild military imagination. It was a meticulously planned, technically detailed proposal to establish America's first permanent military outpost on the moon by 1966. The project's genesis could be traced to a series of increasingly urgent meetings in late 1958 as American intelligence agencies provided disturbing assessments of Soviet space capabilities. The CIA's estimates suggested that the Russians were not merely content with orbital achievements, they were actively developing technologies for lunar missions. If the Soviets reached the moon first and established a military presence, the strategic balance of the entire Cold War could shift permanently in their favor. Lieutenant General Arthur Trudeau of Chief Army Research and Development became Project Horizon's most passionate advocate. A decorated World War II veteran who had witnessed firsthand how technological superiority could determine the outcome of global conflicts, Trudeau understood that the moon represented the ultimate strategic position. From a lunar base, he argued in classified briefings, we could observe every missile launch, every troop movement, every naval deployment anywhere on Earth. More importantly, we could respond to threats with weapons that would be virtually impossible to intercept or counter. The technical specifications of Project Horizon read like something from the pages of a Jules Verne novel, yet every detail was grounded in the cutting-edge engineering of the time. The proposed lunar base would require 147 rocket launches over a 2-year period, delivering approximately 220 tons of equipment and supplies to the moon's surface. The base itself would house 12 military personnel initially, expanding to accommodate up to 20 soldiers, scientists, and technicians. The base's primary structure would consist of prefabricated cylindrical modules, each weighing roughly 1,200 pounds, and designed to be transported in the cargo bay of the proposed Saturn rockets. These modules would be connected underground, providing protection from the moon's harsh radiation environment and the constant threat of meteorite impacts. Solar panels would provide power during the lunar day, while nuclear reactors would maintain operations during the 2-week lunar nights. But Project Horizon's true purpose extended far beyond mere habitation. The base was designed as a comprehensive military installation capable of multiple strategic functions. Advanced radar arrays would provide early warning of intercontinental ballistic missile launches from anywhere on Earth, giving American defense systems precious additional minutes to respond to Soviet nuclear attacks. Communication equipment would allow the base to serve as an orbital relay station, ensuring that American forces worldwide could maintain contact even if Earth-based communication networks were destroyed in a nuclear exchange. Most controversially, the project included provisions for offensive capabilities. While the specific weapon systems remained highly classified even within the project itself, declassified documents suggest that planners considered everything from conventional missiles launched from the moon's low-gravity environment to more exotic concepts involving kinetic bombardment, essentially dropping heavy objects from lunar orbit to strike targets on Earth with devastating effect. The logistical challenges were staggering. Every pound of equipment, every drop of water, every breath of air would need to be transported across 250,000 miles of empty space. The planners calculated that establishing the base would require developing entirely new categories of spacecraft, including heavy-lift rockets that dwarfed anything then in existence, specialized lunar landing vehicles capable of delivering multi-ton payloads, and life support systems that could operate reliably for months or years without resupply. The human element presented equally daunting challenges. The soldiers selected for lunar duty would need to be part astronaut, part engineer, and part warrior, capable of operating in an environment more hostile than any battlefield in human history. The estimated cost of Project Horizon, $6 billion in 1959 dollars, equivalent to roughly $60 billion today, represented a staggering commitment of national resources. Yet, for the project's advocates, no price was too high to secure America's position as the dominant military power in space. As one classified assessment noted, the nation that controls the moon controls the Earth. The investment required to achieve this control is insignificant compared to the strategic advantages it would provide. By late 1959, Project Horizon had evolved from a theoretical concept into a detailed operational plan, complete with timelines, budgets, and technical specifications. All that remained was the political will to transform this audacious vision into reality, and the hope that the Soviets weren't already ahead in their own plans to militarize the moon. While American military planners refined their lunar fortress designs, their Soviet counterparts were engaged in an equally ambitious and secretive effort to ensure that the Red Army, not the U.S. Army, would be the first to plant its banner on the moon. In the closed cities of the Soviet military-industrial complex, projects codenamed Zvezda, Star, and Volcano were pushing the boundaries of both technology and imagination. The Soviet approach to lunar militarization reflected the broader philosophical differences that had defined the Cold War from its inception. Where American planners envisioned a substantial, permanent base that would serve as a visible symbol of Western technological prowess, Soviet strategists favored a more subtle approach, one that emphasized stealth, surprise, and the element of the unexpected that had served them so well in terrestrial conflicts. Sergei Korolev, the enigmatic chief designer, whose identity remained a state secret even within the Soviet Union, found himself at the center of these clandestine efforts. By day, he worked on the publicly acknowledged Soviet space program, developing the rockets and spacecraft that would carry cosmonauts into orbit and eventually to the moon. By night, he huddled with military officials and weapons designers, contemplating scenarios that would have seemed impossible just a few years earlier. Project Zvezda, initiated in early 1958, represented the Soviet Union's answer to American lunar ambitions. But unlike the American approach, which emphasized establishing a visible and permanent base, Zvezda focused on what Soviet military doctrine called asymmetrical response, achieving strategic objectives through unconventional means that would negate American advantages. The centerpiece of Zvezda was a series of unmanned lunar installations that would be pre-positioned on the moon's far side, hidden from Earth-based observation and protected from American surveillance. These installations, each weighing approximately 500 kilograms and powered by radioisotope thermoelectric generators, would serve as automated observation posts, communication relays, and potentially weapons platforms. The genius of the Soviet approach lay in its simplicity and deniability. Unlike a manned base, which would require constant resupply and would be vulnerable to attack, these automated installations could operate for years without maintenance. More importantly, their small size and remote location would make them virtually impossible to detect from Earth, allowing the Soviets to establish a military presence on the moon without triggering the kind of international crisis that a visible base would inevitably provoke. Colonel General Kamanin, head of cosmonaut training, and one of the few individuals cleared for full knowledge of Zvezda, outlined the project's strategic rationale in the classified memo dated September 58. The nation that controls the Earth thinks in terms of overwhelming force and visible demonstration of power. We must think differently. A single weapon, properly positioned and completely hidden, can be worth more than an entire army base that announces its presence to the enemy. Project Volcano represented an even more audacious concept, the pre-positioning of nuclear weapons on the lunar surface. The project planners, working under the direction of the Ministry of Defense's Special Projects Division, envisioned a network of nuclear devices buried beneath the moon's surface, each capable of being activated by radio signal from Earth. The strategic logic was chilling in its simplicity. In the event of nuclear war, these lunar-based weapons could be detonated in a coordinated pattern, creating electromagnetic pulses that would disrupt satellite communications and potentially damage orbiting spacecraft. More dramatically, the weapons could be configured to propel large masses of lunar rock toward Earth, creating artificial meteor showers that could devastate specific geographic areas. The technical challenges of Volcano were immense. The weapons would need to be specially hardened to survive the journey to the moon, the shock of landing, and years of exposure to cosmic radiation and extreme temperature variations. More problematically, the project required developing reliable command and control systems that could function across the vast distance between Earth and Moon, while remaining secure from enemy interception or jamming. Soviet intelligence agencies played a crucial role in both projects, tasked with determining the extent of American knowledge about Soviet lunar military activities. Through a network of agents and sympathizers within the American aerospace industry, the KGB gradually assembled a picture of Project Horizon and other American lunar military initiatives. This intelligence allowed Soviet planners to tailor their own projects specifically to counter American advantages. The espionage aspect created a feedback loop of escalating ambitions. As each side learned more about the other's capabilities and intentions, the scope and scale of their lunar military projects expanded. What had begun as theoretical studies evolved into detailed operational plans, complete with timelines, budgets, and technical specifications. All that remained was the political will to transform this audacious vision into reality, and the hope that the Soviets weren't already ahead in their own plans to militarize the moon. The year 1961 marked a turning point in the secret lunar arms race, though not in the way either superpower had anticipated. As engineers on both sides of the Iron Curtain struggled to transform their ambitious military concepts into working hardware, the harsh realities of space technology began to assert themselves with unforgiving clarity. The first cracks in the American lunar fortress dream appeared during a series of technical reviews conducted in early 1961. Project Horizon's timeline called for the first construction missions to launch by 1965, but NASA's own assessments revealed that the Saturn rockets necessary for such missions wouldn't be ready until at least 1967, and that assumed no major technical setbacks. More troubling, the life support systems required for long-duration lunar operations were proving far more complex and unreliable than originally anticipated. Dr. Wernher von Braun, the former German rocket scientist who had become America's leading advocate for space exploration, delivered a sobering assessment to Pentagon officials in March 1961. "We are attempting to solve in 5 years technological challenges that may require 15 or 20 years of development. The moon is not merely distant, it is actively hostile to human life in ways we are only beginning to understand." The Soviet Union faced equally daunting technical obstacles. The automated systems at the heart of projects Zvezda and Volcano required levels of reliability and autonomy that pushed 1960s technology far beyond its limits. Soviet engineers discovered that the electronics needed to survive years of lunar operation would need to be completely redesigned, using materials and techniques that didn't yet exist. The nuclear devices envisioned for Project Volcano presented even greater challenges, requiring miniaturization and hardening technologies that were still in their infancy. But perhaps the most sobering reality was economic. As both nations began to calculate the true costs of their lunar military ambitions, the numbers became staggering. The American Office of Management and Budget estimated that a fully operational lunar base would require sustained annual expenditures of $2 to $3 billion, roughly equivalent to $25 billion in today's dollars. For a nation already straining to fund the conventional arms race, the space race, and growing commitments in Vietnam, such expenditures represented an impossible burden. The Soviet Union, despite its reputation for unlimited state resources, faced even more severe constraints. The command economy that had enabled rapid industrialization in the 1930s was proving inadequate for the complex, technology-intensive requirements of space warfare. Critical components required precision manufacturing capabilities that simply didn't exist within the Soviet industrial base, forcing planners to choose between massive new production facilities or continued dependence on technologies that were fundamentally inadequate for lunar operations. The human costs were equally daunting. Both superpowers had vastly underestimated the psychological and physiological challenges of long-duration space operations. Early orbital flights had revealed that even short periods in space produced significant medical effects, from bone loss to cardiovascular deconditioning. The prospect of maintaining military personnel on the moon for months or years raised questions about human performance and reliability that had no easy answers. Radiation presented perhaps the most intractable challenge. Unlike Earth, the moon had no atmosphere or magnetic field to protect against cosmic rays and solar radiation. Military personnel stationed on the lunar surface would be exposed to radiation levels that could cause cancer, genetic damage, and acute radiation sickness. The shielding required to protect against such exposure would add massive weight to any lunar installation, further complicating the already overwhelming logistical challenges. As these technical and economic realities became clear, political pressures began to mount for a different approach to space competition. President Kennedy's advisors, led by Secretary of Defense Markham McNamara, increasingly questioned whether lunar militarization was either feasible or necessary. The development of intercontinental ballistic missiles had already provided both superpowers with the ability to strike anywhere on Earth within minutes. The additional capability provided by lunar weapons platforms seemed increasingly marginal compared to their enormous costs. The Cuban Missile Crisis of October 1962 provided a stark demonstration of how quickly the Cold War could escalate toward nuclear catastrophe. The crisis also highlighted the importance of communication and de-escalation mechanisms, precisely the opposite of the isolated autonomous weapons systems envisioned for lunar deployment. The idea of pre-positioned nuclear weapons on the Moon, beyond the reach of normal command and control systems, began to seem not just expensive but actively dangerous. International law provided another constraint on lunar military activities. The Outer Space Treaty, negotiated throughout the mid-1960s, explicitly prohibited the placement of weapons of mass destruction in space or on celestial bodies. While both superpowers initially resisted such restrictions, the treaty provided a face-saving way to abandon military lunar projects that were proving technically and economically unfeasible. The treaty's negotiation revealed just how seriously both sides had considered lunar militarization. Soviet negotiators initially insisted on language that would permit defensive installations on the Moon, while American diplomats pushed for exceptions that would allow scientific installations with obvious military applications. The final treaty language, prohibiting all military installations on celestial bodies, represented a mutual recognition that the lunar arms race had become too dangerous and expensive to continue. By 1967, both Project Horizon and Projects Zvezda and Volcano had been quietly terminated. The official reasons cited budget constraints and shifting priorities, but the underlying reality was that both superpowers had concluded that lunar warfare was neither technically feasible nor strategically necessary. The Moon would remain, for the foreseeable future, a destination for scientific exploration rather than military conquest. The cancellation of these projects marked the end of the first and perhaps last serious attempt to extend terrestrial military conflicts beyond Earth's atmosphere. The harsh realities of space technology, combined with economic constraints and international pressure, had succeeded where diplomatic appeals for peace had failed, in keeping the Cold War's weapons earthbound. Though the secret lunar military projects of the 1960s never progressed beyond the planning stage, their influence on subsequent space policy and military doctrine proved both profound and enduring. The technical challenges that doomed Project Horizon and the Soviet lunar weapons programs became the foundation for more realistic approaches to space-based defense systems, while the strategic concepts developed during this period continued to shape military thinking well into the 21st century. The abandonment of lunar militarization didn't end military interest in space, it simply redirected it toward more achievable objectives. The technologies developed for lunar warfare found new applications in Earth-orbiting surveillance satellites, communication systems, and eventually the Strategic Defense Initiative of the 1980s. The same engineers who had designed lunar fortresses turned their attention to orbital platforms that could track missile launches, intercept incoming warheads, and provide global communication networks for military forces. The psychological impact of the lunar arms race extended far beyond the classified world of military planning. The very fact that both superpowers had seriously considered weaponizing the moon demonstrated the extent to which Cold War competition had distorted national priorities and strategic thinking. The enormous resources devoted to these ultimately futile projects represented one of the most expensive dead ends in military history, consuming billions of dollars and thousands of engineering hours that might have been applied to more productive purposes. Within the American military establishment, the failure of Project Horizon led to a fundamental reassessment of the relationship between technical ambition and strategic necessity. The project's advocates had assumed that any technical challenge could be overcome with sufficient resources and determination, but the lunar environment proved resistant to such optimism. This experience contributed to a more cautious approach to military space projects, emphasizing incremental development and realistic assessment of technical risks. The Soviet experience was equally instructive, though for different reasons. The cancellation of Projects Zvezda and Volcano highlighted the limitations of the command economy in addressing complex technological challenges. Unlike conventional military hardware, space systems required levels of precision and reliability that couldn't be achieved through brute force industrial methods. This realization contributed to broader reforms in Soviet technology development, though these changes came too late to prevent the ultimate collapse of the Soviet system. The international diplomatic legacy of the lunar arms race proved more positive. The Outer Space Treaty of 1967, negotiated partly in response to fears about lunar militarization, established important precedents for international cooperation in space. The treaty's prohibition on weapons of mass destruction in space, while not preventing all military space activities, did succeed in keeping the most destabilizing weapons Earth-bound. More importantly, the treaty established the principle that space exploration should benefit all mankind rather than serving narrow national interests. As we move deeper into the 21st century, the lessons of the 1960s lunar arms race have taken on new relevance. Private companies like SpaceX, Blue Origin, and others have dramatically reduced the cost of space access, making lunar missions economically feasible for the first time since the Apollo era. Simultaneously, new space powers including China, India, and commercial entities are developing independent capabilities for lunar exploration and potentially lunar resource extraction. This new lunar economy has revived some of the strategic concerns that motivated the original military space project. Control of lunar resources, particularly water ice that could be converted to rocket fuel, could provide decisive advantages in future space operations. The nation or organization that establishes the first permanent lunar industrial base could effectively control access to the rest of the solar system, creating the same kind of strategic imbalance that American and Soviet planners feared in the 1960s. The technical challenges that defeated the earlier lunar military projects have largely been solved by advances in robotics, artificial intelligence, and materials science. Modern space systems are far more reliable and autonomous than their 1960s counterparts, while manufacturing techniques like 3D printing could enable lunar installations to become self-sustaining in ways that were impossible during the Cold War era. The question is no longer whether lunar militarization is technically feasible, but whether it is strategically desirable. The emergence of space as a domain of military competition has already begun, though in forms quite different from those envisioned in the 1960s. Anti-satellite weapons, cyber attacks on space systems, and electronic warfare in orbit represent the new frontier of space conflict. These capabilities are far more subtle and deniable than the lunar fortresses once planned by both superpowers, but they may be equally destabilizing in their ultimate effect. Perhaps the most important lesson from the secret lunar arms race of the 1960s is the danger of allowing military thinking to drive space policy. The enormous resources devoted to Project Horizon and the Soviet lunar weapons programs produced no lasting benefits for either nation while delaying more productive applications of space technology. The scientific and commercial benefits of space exploration, from satellite communications to weather forecasting to GPS navigation, have proven far more valuable than any military application ever conceived. As humanity stands on the threshold of a new era of lunar exploration, the choice between cooperation and competition remains as relevant as ever. The moon that once seemed destined to become a fortress could instead become humanity's first stepping stone to the stars, only if we learn from the mistakes of the past and choose exploration over militarization, cooperation over competition, and hope over fear. The secret lunar arms race of the 1960s serves as both a warning and an inspiration, a warning about the dangers of allowing military thinking to drive space policy, and an inspiration about what humanity might achieve when we direct our technological capabilities toward peaceful purposes. The moon still hangs in our night sky, unchanged by the ambitious plans once made for its conquest. Whether it remains a symbol of peace or becomes a battlefield for future conflicts depends entirely on the choices we make today.